Let's get started for chapter 5, conditionals and logic. Conditional and logic. Okay, so far we work on some numbers. We mainly on numbers. We're working on real number. So we get double X, Y, U, V, whatever. Right? Now we are going to talk about another data type called Boolean. Actually, it's like done or something like found. Okay, and it will be true or false. The value will be true or false. Okay, that's the logic we are working on, are going to work on. So that's the logic and conditional. Okay, before we jump into here, let's go to a program. I would like to use another one. So now, instead of using chapter 4, I'm going to new a project. In my project, same thing like yours. I create a folder called chapter 5. So this gets things organized. When you later come back to review something, you will be organized. So here, yes, no program. So here we have a yes, no program, okay? Inside this yes, no program, we have public static void main. Right here, okay. Then I will have Boolean. Okay, I can have a Boolean called yes equals true. Then I'll do if yes. Okay, so here I have a simple program. I set the value true to yes. And if yes equals true, then I would say I'm yes. Otherwise, I would say I'm no, okay? That's a pretty simple program. So run, I'm yes, because I said it's true. But so true is TRUE lowercase is for logical truth. Okay. Now if I say I don't use this, I just type false. So false is for logical negation. Negative value, okay? No good. In that case, I compile again and run again. I got a no now, right? Okay, so that actually is called something we do as Boolean, and then yes equals true. This while yes is called Boolean variable. Okay, that's called Boolean variable. Okay, now let's go into here, and then I put this. I got an integer s equals 0, and then I'll say my Boolean positive, right? And I say if s greater than 0, and then I'll say positive equal true, right? Else positive equals false, right? Okay. And at the same time, I also define another one called negative, right? And I copy the same thing. And then here I say negative. Negative, right? Then I have another one called 0. So if x or I'm sorry, positive or negative, the two line called or, then 0 equal false. So two vertical bar. Where is the vertical bar? In your keyboard is under backspace.
Okay.
That's a bar, and you need to type a shift. You need to shift plus the backslash key. Okay, you will get one vertical bar, but you need two. When you have two, then you set 0 to be false, else 0 will be true. If you are positive or negative, then you don't have a 0. And if you actually are not either positive or not negative, both of them, you are not positive and not negative, then you have a 0. Then right here, actually, yes, very wordy, right? Actually, we don't really need to be doing so much detail. I just teach you what's a Boolean variable, okay? I just try to use this as an example. So if positive, then right, same thing. I can copy this for 3 times. I'm sorry. Okay. Compile. And right here, let's run it. Okay. Because I set x equals 0, so I got the 0. So anyway, before everything, I still print the backslash f again. And compile. And then I run one more time. So I know because I set it to false, right? And then 0 and 0. Now let me put 10. Is that okay?
Yeah.
Then I get I'm positive, right? And then now I put a minus sign there. I just show you like how the whole thing works, right?
Yeah.
So Positive, negative, 0, they are all Boolean variables. Okay, and this one, you assign some Boolean value to a variable. You can call this as a Boolean assignment. Okay, and then this one you have, actually you have this one, positive or negative. This one is called Boolean expression. Is that okay?
Yeah.
And then this one, 0 equals true, the whole thing. This one is called Boolean statement. So Boolean statement, actually, Boolean assignment is one kind of Boolean statement. Is that okay? Now the next things, right here. Right here I have public static Boolean greater, and then I have integer A, integer B, okay, if A greater than B, I return true. So here I have a Boolean expression. If A greater than B, I return true. If A not greater than B, I return false. So the whole thing greater is a Boolean what? So greater should be a Boolean what?
Expression? Wait, no.
Greater is what? Remember chapter 4. Chapter 4 is talking about what? Function or method. Is that okay?
Yeah.
That's a Boolean function or Boolean method. Okay. Now I finish this. Now let's try. So system.out.print9. I put greater 3 and 5. 3 and 6. Fine. Copy this one 6 and 3. And before that, I print 3 greater than 6 is, here I put 6 greater than 3 is, and right here, a plus sign here, and that's wrong. And then that's wrong here. 3 greater than 6 is false. 6 greater than 3 is true. So here I talk about a few things. Boolean variable, I'm sorry, let me clean this. I don't like this. Using this one. Boolean variable, Boolean expression, right? Boolean statement, and the Boolean function. Boolean variable is like this y or like a 0 is a Boolean function, right? Or positive or negative. Boolean expression is the positive or negative, right? Boolean statement is like 0 equals, actually equals g equals 0. And then Boolean function is like f of 3, 6, this type of thing. That one is Boolean function. Okay?
Okay.
So 4 different kind of Boolean value that you can obtain. That's actually the 4 different type of Boolean value. Now, where to use our Boolean function, a Boolean value? First one, we have the logic. We have Boolean variable, Boolean statement, Boolean expression. After that, we can use 6 type of Boolean operators. So this Boolean operator, you have double equal sign that is equal. And then let me ask you a question. What is the single equal sign actually means?
That is
Single,
like
single equal sign.
like to a number.
Assignment, right? It's assigned
Yeah.
number variable. So the real check-in for the equals is using double equal sign, okay? And then exclamation mark with equal sign, that's m equal, that's actually not equal to. Greater, less than, greater than, less than. This one greater than or equal to. This one less than or equal to. That are 6 relational operators. Is that okay?
Yes.
And each one of these is called a Boolean expression. Boolean expression is by 2 Boolean operands and 1 Boolean operators.
Mm-hmm.
And the Boolean expression will give you true or false. Okay, and it's a relational operator, so, but this doesn't exist. Always less than on the left hand side. But mathematically, you may see something like this. Now you need to use this. You may see this. Now you need to see this. You need to see this. You may see this. Now you have to use this. Okay? Left hand side is a mathematical symbol, right hand side is Java symbol.
Okay.
Is that okay?
Yeah.
Now we move to the if then else. Actually, we have used that, right? If positive, we do something.
Yeah.
If 0, we do something. So that is the if statement. That actually is you will have an execution flow of this. You do something, true, you go down. Do something false, you go another way. You bypass, right? That's a single if statement. If true, we go to the box. If no, you just bypass the box. That's a single if statement. Then there's another statement called if else statement. So now I have to give you a test. Here you have the x 10 modular by 2. What does that mean? This one equals 0. X 10 modular by 2 equals 0. What does this mean?
It means
If this is true, what is x?
that x is an even.
X is a multiple of 2.
Oh yeah.
And then it's even, okay?
Mm-hmm.
If not, it's an odd number. So right here, actually you have x 10 modular by 2. If true, you do this, or otherwise you do that. You actually have this. If it's true, you do this. If no, false, you do this, and then you combine them together, go down. Okay, that's a if then else statement. It has an if else statement. Okay, and here you just read it. Okay, I teach you what's a positive, what's a negative already.
Yeah.
And this actually done. 5.3 chaining and nesting. So it actually is possible that you chain the if then statement. So
yeah.
if s greater than 0, we do so and so, else, right? If x less than 0, we do so and so, and then else we do so and so, right? But if you write something like this, you can also write something like this. Which one's better?
Wait. Else.
Is the right hand side better or left hand side better?
The same thing.
They work the same, yes. They work the same. They work in the same way. But which one is better?
Oh. The right one?
Why? Why do I want is better?
Because wait, the right one doesn't have the braces.
Braces I can add it. No, you consider it braces is not a problem.
Oh. I don't know.
It's more related to indentation, right? So actually, if else statement is not too many, right hand side is better because I know that which else is following which one, right? Okay. If there is not too many, but if I have some function like if s greater than 90, right? Then my grade equals a. Else if s greater than 80, and grade equals b. Right? And else if s greater than 70, and my grade equals c, right? Something like that, you can continue. Then if you tilt it, it will become like this. It's not readable. So in that case, if you have too many of the event nails, keeping it aligned to the lab is better. So the answer actually, the question I asked you actually, the answer is depends. Depends on your condition. Usually the option are too many. This is better. If it is few, that may be better. Okay. The whole thing is that make things readable to other programmer or yourself actually. That's called chaining and nesting. The next one is the logical operator. The previous one, the six of them are relational operator. Relation, like checking the relation between two numbers. Now this one is logic operator. Logic operator, I have this one exclamation mark called negation. So it means not. Okay, so I have x greater than 0. I can put parentheses and put a pen there. This means x not equal to 0. Actually also means x less than equal to 0. Is that okay?
Yeah.
So single exclamation mark called not, not. Pen. And then your or is double vertical sign. Your end is actually n as s sign. So this one is what the English name is called ampersand, right?
Yeah.
Ampersand. Okay, and you can call it like a and d x sign. Here is called answer, but two of them it perform as a and d logical end, right?
Yeah.
And or using the vertical bar because here usually in the old days when there's no windows, people say beef or lamb or pork, right? When they choose meat, they write down. So this one is actually like or. But here in Java, we use two vertical bars or.
Okay.
Is that okay? So now we have this. If x equals 0, then inside there, if y equals 0, this actually means if x equals 0 and y equals 0, we do this. Is that okay?
Yeah.
And here x equals 0, else if y equals 0, we do the same thing, but we can combine as x equals 0 or y equals 0, we do this, you know? So that's a logical combination. So there is a simplification and combination need to be done. But usually if the first one is true, the first one already been true, we will not execute the second one. That's called short-circuiting evaluation. Well, when will people use the short-circuiting? I'll show you a short-circuit. Okay, I'll show you a short-circuit. Short-circuiting is very important in Java or any programming language. So let's do public static void and now I want to have short-circuiting. So I have integer a equals 3, integer b equals 0, and then if b not equals 0, and a divided by b greater than 3. Then we say system.out print line a is 3 times larger than b, right? Is that okay? What will happen to this?
If b is not equals nothing, because b is equal to 0.
Yeah, nothing will happen. But here, if I cut this guy out, right? Put it as a comma, compile, no problem, right? But when I run it, wait, it creates a arithmetic exception because division by 0
is
undefined. Or actually in mathematics, it actually is infinity, right?
Yeah.
But when I put this back, it actually works because I never checked the second part. When my first part is false, I go through. This is called short-circuiting. Is that okay?
Yeah.
When there's a logical check, and the first part is false, and followed by an end, the second part won't need to be changed. No need to check because it's already wrong. Okay, here I write another short-circuiting, but it's different logic. Here I have this one equals a equals 3, b equals 15. System.out print line, I'm happy.
It would print out I am happy.
And the second part is not true.
Yeah, but it's or, so only one of them.
Yeah, so basically what will happen is we go through here, this one is actually not true, so we go past. This one completely not executed. This one I hit a 3. It already be true, so I jump to here, continue to true. The second part never been done. Never been done. So even if I do this, I don't put a b equals 15. Instead of doing that, I actually copy this. Right? Suppose if I try to evaluate the second part, I will have trouble. Right? But in fact, it won't. Your first part already short circuit. Provide a result and it's gone. It's now gone. Let me clean this. Right? Is it gone? Is that okay? It's called short circuiting. And let me see, pulling measure, validate the input, example program. It's not going to finish within an hour, okay? Are you okay? Probably we will end today up to 5-4, okay?
Okay.
Then we have second half of the program continuing. So let me see, chapter 5, if there is something you can work on. 1 seems okay. Or output of without using the computer. 2 seems okay. Rewrite the if statement. 3 seems okay. 4 is not. So chapter 5, work on 1, 2, 3.
Okay.
So let me write it down. Chapter 5, 1, 2, 3. Okay. You will have enough fun.
Okay.
Okay. So I'll send you this different example program to you.
Okay.
Now let me check. Okay, I post directly to you. I have today I use the program stack, right? In chapter 4. And then chapter 5, I have the yes, no, and short circuit. Okay, now I post it for you, okay? Right away. So I have chapter 4, I have program stack. Chapter 5, I have this short circuit. I have yes, no. Okay, then thank you, and we are done here. Bye now.
Okay, thank you. Bye.
Bye-bye.